Okay, good day class. Now we will discuss about implicit functions and polynomial curves. So first, let's discuss implicit function. What is an implicit function? So in general, an equation involving x and y determines a value or values of y corresponding to each value of x in some range, and therefore determines y as a function of x. Hitherto, we have been concerned with functions defined explicitly by an equation of the form y equals f of x. So this form in equation 1 is an explicit function because y is expressed explicitly as a function of x. So you can isolate y on the left side, and then the right side contains only the independent variable x. So it may happen, however, that x and y are connected by an equation not solved for y. For example, x cubed plus y cubed equals 3axy. So in this equation, you cannot express y explicitly as a function of x, meaning you cannot isolate the variable y on one side of the equation. So these functions are called implicit function of x. So in contrast to our equation 1, an implicit relation between x and y will be written as f of xy equals 0. So in equation 2, f of xy is a function of two arguments or variables x and y. Okay, so how do we solve for the derivative of implicit functions? So to find the derivative of a function defined implicitly, we apply the following procedure. So this is just a simple rule. So to find the derivative, we simply differentiate each term of the equation f of xy equals 0 with respect to x, bearing in mind that y is a function of x. So in this connection, it must be remembered that the derivative of y raised to n with respect to x is n times y raised to n minus 1 times the derivative of y with respect to x. Okay, so here, if you recall our last module, the general, the power formula of the derivative of y raised to n. Okay, so before we proceed to the other topics, let's just solve first our sample problem for the implicit function. Okay, so our problem number 1, find the derivative of y with respect to x of the following function. Use the given relation in its implicit form. So the quantity x squared minus y squared squared equals 4ay cubed. Okay, so class, this is an implicit function because you cannot isolate one variable on one side and then the other variable on the other side. So we just differentiate each term of this function. So we directly differentiate. Okay, so let's write first our equation. X squared minus y squared equals 4ay cubed. So let's first differentiate this term. So using the general power formula, so this will become 2 times x squared minus y squared. Okay, 1 na lang. And then times the derivative of the yung nasa loob. So this becomes 2x minus okay, wait. 2x minus 2y times the derivative of y with respect to x. Okay, equals 4a. times 3y squared times the derivative of y with respect to x. Okay, so let's distribute and simplify. We have 4x times x squared minus y squared minus 4y times x squared minus y squared dy over dx equals 12 y squared, the derivative of y with respect to x. Okay, since we have a common factor 4, we can factor it out. So this becomes, and then let's transpose this term to the right side. So we have x times x squared minus y squared equals 3 ay squared plus y times x squared minus y squared. Okay, we factor out the common factor, that is the derivative of y with respect to x. X times equals 3ay squared plus y times x squared minus y squared dx. Okay, so okay, now we isolate the derivative of y with respect to x. So this becomes x times x squared minus y squared all over y times x squared minus y squared plus 3ay squared. We can, this still has a factor, a common factor, that is y. So we can still simplify this term, so that our final answer will be x times x squared minus y squared over y times x squared minus y squared plus 3ay. Okay, so this is the derivative of our given function. Okay, now let's move on to the next topic, that is the tangents and normals to plane curves. Okay, so I'll just stop the video here and I will make another video for that. Okay, para maikli lang ang mga videos natin, class. Okay, thank you.